Alright, so I have just come home to the realization that me and my group don't have a name. And if I leave it without a name, it might affect our grade. So, I can name it whatever I want, because no one can stop me at this point. Because it's due tomorrow and I need to finish some editing. And I have come up with a great name, and that name would indeed be the Masters of Shrek Swaggington. Yes, the Masters of Shrek Swaggington is our group name. So you can just write that down. Masters of Shrek Swaggington. Swaggington is spelled Swagington. Swaggington.
Bill Nye the Science Guy.
What are you doing in my swamp?
Bill Nye the Science Guy.
Science rules.
Bill the Astronaut.
Inertia is a property T minus 7 seconds.
Bill Nye the Science Guy.
We the wall! XD.
By God, what was that? Was that motion? By God, hot diggity dog, do I wish I could learn about that right about now. I hope some masked heroes come in and save the day.
Did you know? So if we slide the books, it will move at a certain speed until it stops due to friction.
Oh, great.
The books, it will move at a certain speed until it stops due to friction.
Alright.
That means start.
Oh, we can do that for
Ready,
math.
set, okay, go. Okay.
Newton's
second law of motion is force equals mass times acceleration.
Which means the greater the mass, the greater the amount of force will be needed. Take that.
Okay, so a lot of stuff just happened that you missed. Well, first of all, while I was trying to do an experiment, I spit water all over myself, so I got a nice new change of clothing. Hope you like it. Oh God! See, I almost fell again. Alright, so anyway, let's just move on to what I was gonna do. Now, we've already had an example of this third law, which is, for every action, there is an equal and opposite reaction, alright? This third law. Pretty dank law, in my opinion. Alright, so what happened was, you might have saw it, and you may have noticed it, but Starlin blew up a balloon, right? And then she let it go.
He's filming.
I can trim anything we don't need.
He's filming.
Alright. And then it flew away. Like, woo! And, you know, that's because, like, the air in the balloon pushes back out of the balloon where it wants to go. It wants to go on the outside, be free. But this balloon, because all the air is pushing out so fast, it flies off into the distance to acquire its true goals of becoming a rock singer. I don't know. Hey now, you're an all-star. Get your game on. Go. Hey now, you're an all-star. Get your game on. Go. Play. And all the glitters is gold. So, what we need to explain to you is the distance, speed, and timetable, which will be right here. Yeah. Alright, so this table, distance, alright? Distance, that's how far you will be traveling. Is your time, alright? Time, alright, that's an amount of how long something would take, alright? Speed, pretty good. I like speed, because that's how fast you'll be going. Zoom, fast. Yeah, so if we take distance, alright, if we're trying to find distance, we're going to hold this down, we multiply speed and time. All right. And if we're trying to find speed, we're going to fold that. All right. And what does that give us? That'll give us distance divided by time. That'll give us our speed. And then if we take our speed or our time and we fold that over, we get distance divided by speed. All right. So now we got distance, speed, and time table. What else do we need? We need a mass and acceleration table. All right, force is at the top, mass over here, and then acceleration right here. Now it's the same principle. If we fold down force, we get mass times acceleration. Force equals mass times acceleration. And then if we fold over mass, we get force divided by acceleration. That will give us our mass. And if we fold over acceleration, we divide force by our mass. We will get our acceleration. Very, very, very simple, very meaningless. Alright, that'll do it. Okay, so I forgot to work in the word variable in either of those. Now what a variable is it's just a factor in an event. That's the best way I can explain it. I hope you like variables, huh? 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 Yeah, pretty dank. Alright, so you're probably like, William, what was that? I don't even know what that was. So, I'll tell you what that was. That was net force at work. Me and Sully were pushing each other away, and Sully had a greater force, we'll say of, 30 newtons, and I was pushing back with a weaker force of 20 newtons, why not? And that would mean our net force, since I'm pushing this way and he's pushing the opposite direction, that would be a net force of 10. And if we wanted to get a little more specific, that'd be 10 points. We'll just say he was pushing this way, so it'd be 10 newtons. We'll just say this is east. 10 newtons east, why not? Here's a diagram. But if we were pushing, like, let's say we were pushing a box or something, like the same direction. We'll just say we're pushing a box the same direction with the same amount of force. He has 30, I have 20. And since we're pushing the same direction, working together, all right, pretty dank here. We have a net force of 50, so it's better to work together. You see, understand it. The more you know. I don't know. Diagram. Alright, so what you just saw was a nifty home experiment, if I do say so myself, and, basic supplies, a balloon, some fishing line, tape, a straw, and all you gotta do is tape the straw to the balloon, feed the fishing line through, pull it tight on both ends, blow up the balloon, let go, and it shoots down the line, because of all the air in the balloon. I already explained that earlier, but, yeah, it's pretty dank, and we collected some results on how long it took and how far it went, and we got our speed, and I will show you that now. Alright, so here's the balloon data. Alright, so in here, it traveled 6 meters in 6 seconds, alright? So then we just divide distance by time. 6 divided by 6, that's 1 meter per second. And we'll just do that for all these here. Alright, so looking at all the data, we roughly traveled 2 meters a second almost every time, except these two. Don't know what happened there. Somebody once told me the world is gonna roll me. I ain't the sharpest tool in the shed. She was looking kind of dumb with her finger and her thumb in the shape